Okay, so we're going to start. So welcome everybody to this tech cluster meeting. We are delighted to have today Professor Riccardo Rovatti from the University of Bologna. And as you can see from the slides, the title is very interesting, provocative. So we are happy to learn about explainability or not. And so let me just say a few words about the format and then about Riccardo. And for those who are online, you will have opportunity to ask questions. We have someone checking the questions in the chat. So the format of this type of meeting, as in the past, is that Riccardo will give a talk about 30-45 minutes. It's up to you, Riccardo. Then we will have plenty of time for interaction. That's the format of our meeting at the tech cluster. So a few words about Riccardo, not few because there is not much to say. Actually, there is a lot to say about Riccardo. He is a full professor at the University of Bologna in at the Department of Electrical, Electronic and Information Engineering. I'm reading because I know it's a slippery slope. Yeah, right? Okay. Exactly. And he's actually currently the head of department. Riccardo has worked on several topics that are really of major interest for what we do at the tech cluster. He has published more than 300 papers. Short ones. The typical engineering papers, which is 4 or 5 pages, I would say. Yes. Okay. Still, it's a lot. And is fellow of IEEE, which is the most prestigious association, academic association in engineering. He has been editor of the transaction of that association, which is again the top journal. So really a lot to think, good things to say about Riccardo, but I think we want to hear from you. And so Riccardo, the floor is yours. Thanks a lot for being with us today.
So I would like to say, we'll see whether everybody can hear me. If it is not the case, of course, I will sit down regularly. And first of all, let me thank both Giacomo and Giovanni because the idea of this seminar came out. Oh, yes, for the invitation. Also, Nicolas, of course, but I was thinking about you too because the idea of this seminar came out in a very interesting dinner we had in Bologna, right? And also, thank you for inviting me in this incredible setting because I've been in views for the first time when I entered the main gate and then coming up here, and I'm very happy to be here. So the title I proposed to them, and I'm very happy that Nicolas was agreeing on this, is I want to have a look at the main word that goes around in AI nowadays, which is explainable AI. I want to look at this with let's say a critical eye, but not against that, but just to frame this term in some way. And I hope you will appreciate that this be an AI seminar in which ChatGPT and GPT will be mentioned only once. Okay, that's I think this is the main answer to what I'm saying today. So, no, I have to. Maybe just. I was thinking. Okay, this is the background I have on the UE page for my seminar. Okay, and this immediately gives you an idea that we humans have a problem with AI because this is not explainable to all. What is it? I mean, there's the need for explainable AI, and then you put this as a background, of course, the zeros and ones and the blue things and so on. So we humans do have a problem with the AI currently because we don't understand how it works, and that's true. But what I want to introduce you is a different meaning for AI. I would like to call it alternative intelligence. And it is not my term. Though I had the opportunity of going through Google for this term quite a few times, and I didn't find a lot of people using it. I think this is quite interesting. The first mention I found about alternative intelligence instead of artificial intelligence for the acronym AI is by Professor Negrotti, and actually it is quite obscure publication, and that you see cited there. And the main topic, the message was, okay, we are here because we had some intuition about how the neurons, the biological neurons work, and we tried to change it into machines. Okay, now we did that. Now it's time to stop, because there's no real biological analogy with how human intelligence and intelligence in animals even is developed, because what I would call the biological neuron and the NVIDIA neuron, okay, are completely different, and they are two completely different things. And the second one behaves in a different way. I would like to extend this concept to this. When it is useful, lawful, and profitable, okay, please don't only forget about the biological analogy, but also forget about an analogy on the two things that are artificial intelligence and human intelligence. Assume that they can be completely different. Try to cope with this concept, because sometimes it can be useful, it can be lawful, it can be profitable, and we will see whether this can be understood as a true thing or not. So my idea is that I will speak about alternative intelligence, thinking that it is different, it is not us.
Some people speak also of alien intelligence.
Yes, that's it. You will see it in a minute. You will see it in a minute, because I have to say that in the industry, everybody knows it. I don't know whether you are familiar with this meme, but it is here. You see, he stated December 2022. It is quite a well-known meme that says, okay, what we are doing is just having a monster, a Shoggoth, which is a creature invented by H.P. Lovecraft quite a long time ago. And what we are doing, for example, for having, this is the only mention of ChatGPT, a chatting system, is to place a mask on it so that it resembles a human being or something more human. And that mask is enough for us not to ask anything. Nobody asks whether ChatGPT is explainable or not. Okay, it has a mask, but inside there's a monster. And this is something written by a technician. And actually the community in which this meme was quite widespread is a technical community. Everybody knows that the core algorithm of artificial intelligence is actually alternative intelligence. And this brings to the summary of the talk. Regrettably, I'm an engineer, so I will go down to examples, because engineers have troubles in thinking in general terms. They want to see systems working and performance going around. So I will have more or less 4 main points. First, I'm trying to summarize what I think can be an explanation of explanation. So what is an explanation and why AI is difficult to explain? And then I would like to briefly introduce the fact that explainability is a cost. And then first, some trivialities, something that everybody can tell you. And second, an example we've been working with in our lab, just to establish that there's a real problem. Once you ask that something is explainable, you will lose something else, so that it is a cost.
Riccardo, sorry. We just received the feedback from...
Okay, so sit down, no problem. Okay, but it is almost impossible. Okay, so that's good.
We are hosted by the law department. That's the...
So, okay, so this is the rule. I will obey the rule. So I'm sorry for not being clear before. So the second bullet will be about the cost of explainability. And furthermore, I will detail a further example in which unexplainability is actually a design goal for a system. So what we are aiming at is something that it is not explainable. And then from these 2 main bullets in the center of my talk, I will come to some conclusion. And if technology assists us, to some fast forward glimpse of the future. The first things are very, very light, and then we will go to technical things that I try to develop without any math. So everybody should be confident with this. So my idea is, for example, that explain may mean that I have to convince a human that he or she understands how the current output was generated. So you have a machine, it gives you some output, and then are you convinced of this? Are you okay with that? Can you understand how it was produced? And there's a big difference between understanding the current output or understanding that all the possible outputs of the machines are equally well generated. So explaining something and convincing a human that she or he understands how all outputs will be generated is much more difficult. There are a lot of ideas going around on how I can do this. For example, one way can be generate input examples for each possible output. Okay, you want to explain why it decided it was a dog, then show me some examples of dog images and I will understand how this was decided. Then there's a cat, and so you will need some examples of a cat and so on. Then there is a second way of actually doing things, and I think this is a more serious way, as I will explain this when I give you an alternative model, which is not the original AI, an alternative model that you can understand, you can use, not only understand. So something which is written in Word, because human beings like words to communicate, and you can use these words to reproduce things and come approximately to the same conclusion as the AI. Approximately, of course, because otherwise the AI is useless. So you are able to run this explanation independently to make this game. I'm the computer, I will run this program that I understand. Of course, you are not understanding the program, but you're understanding the description in simple way, in simple words. And then you can generate approximately the same output. Then, of course, if you go through this sequence of increasingly demanding explanations, you end up at the very end with, I will believe you only if you give me a mathematical proof. Okay, that's an alternative, of course. Regrettably, mathematical proofs are only one way of convincing people, and sometimes they fail. One of the reasons why it fails is that not all of us are mathematicians, and so it's very difficult to believe to mathematical proofs if you are not a mathematicians. And the example I'm citing there, which is the quite famous proof of the 4 color theorems in the first version, was a proof that came up to be true that mathematicians didn't believe at the beginning, because it was generated by a very large enumeration of cases solved by computer. It is a proof, it is a mathematical proof, so it must be convincing from some point of view, but actually was not believed at the beginning, even from mathematicians. So the last point is fascinating, but it's somehow tricky, not solving the problem. Okay, it is an extremely simple statement. It says that on a map, when you have regions, no matter how they are arranged, 4 colors are enough to color the map in such a way that no 2 neighboring regions have the same color. This is something that is extremely trivial. Actually, the 5 color version of this, to show that 5 are enough, it's extremely simple. Everybody can do that. And the 4 color is extremely hard. And it took 450 years to be proven since the first statement, despite the fact that it's very simply stated. Okay. And the first proof, actually, it is only the first, because mathematicians didn't believe that and developed the second one and the third one during years, with a approximate time lag of 30 years from one another. Okay. And the first proof was a proof. It guaranteed that it worked, but it was not believed. So explaining things is not a trivial thing. And since I have a lot of meaning for this explain, I will choose number 2 of the second bullet. So I will think that I have explained to somebody something once I have given to him or her a model that she or he can understand and operate with. That is approximately giving the same result. I cannot expect that the model gives exactly the same result, because otherwise I wouldn't need the AI, of course. So we will concentrate on number 2 of the second bullet. Yes, of course.
Can you switch, please, for everybody?
When you say you won't need the AI, of course, if you can generate the same result with the same model, is that entirely true? I think like a lot of AI is used in a sort of cognitive extension of our brain, so we're not really doing things that we wouldn't be able to do otherwise. We're just doing them faster.
We will come exactly to this point.
Okay.
Approximately at the end of the talk. This is exactly one of the main points I will address. Thank you very much. Okay, so assuming that we assuming that we agree on the fact that we can think of an explanation as an alternative approximate model of the AI, let's try to detail something about why explaining AI is so difficult. What you see here is probably at the core of every navigation system. Okay, it's a quite well-known algorithm that it finds the shortest path between 2 points. So it is here, for example. It is almost everywhere. It has many purposes. And this is code. And if you zoom in code, you find English, more or less, and you find something that you can read and understand. If the source is not in the graph is the set of streets and roads you can go through. If the source, so the initial point is not in the graph, of course, you fail. If the destination is not in the graph, you fail, and so on. You see this if, then, do, for. This is English. This can be understood. Of course, you may have to be a technician to read it perfectly. What's the meaning of this? But you can be convinced that it is doing the right thing. And if you zoom in code, you find something like this. If you zoom in a deep neural network, you find something like this. So you basically find some undifferentiated network of neurons, of course, NVIDIA neurons, okay, not biological ones, with a lot of connections between them. And where's the magic? The magic is only in the numbers that are attached to these connections, nothing else. So there's a sea of numbers up there and very little hint about the structures. There's no if, then, else, for, and so on. And this is why it's difficult to understand, because we only have numbers, little structures, and the number of numbers, which are called parameters, is huge. So you find down there, oh my God, there's GPT-3, second mention. I didn't realize it when I wrote the title. Okay, GPT-3, which is the last one of which we know the statistics, had 175 billion parameters. And today, since we don't have the statistic of GPT-4, the largest deep neural networks is the so-called Bagua-Lu. It's a Chinese thing, which is 174 trillions of parameters, 3 orders of magnitudes more in just 2 years. So the number of numbers that we have to read before trying to understand what these AIs are doing is incredibly beyond our human capabilities of making any sense out of a bunch of numbers. So explaining is difficult and explainability is a cost. Here in this slide, I'm detailing what I call trivialities. So something that can come up to my mind immediately when I think, okay, it's a cost because the first is that requiring that something is explainable is not what the engineer call a functional requirement. A functional requirement is something that specifies how you behave. You should make a sum, you should make a multiplication, okay? I don't care how you do it. While explainability is a further constraint, is a further specification. So you have to make a sum and you have to make it this way, or in some way I understand. Okay, so it's an additional specification. And this means that nowadays workflow, so the design flows that engineers and technicians follow to design these huge AIs do not entail explainability at all, because they are mainly concerned with functional specifications, with the performance, nothing else. So, and the community is doing so, we need some work to add this further specification opportunity to our workflows. And this is a cost, of course, not only because we have to renovate our workflows, but also because we have to operate a heavier workload, of course. And then there's another thing that is somehow obvious. AI is based on machine learning, mostly nowadays. Machine learning is a kind of optimization, and optimization is made of a target function and some constraints. You're just adding one constraint. It must be explainable. Further to all the other constraints you may have, you're adding one constraint, and it's very trivial to say that in optimization, if you add a constraint, what your result is more complicated to obtain and probably suboptimal with respect to the situation in which the constraint was not there. So it is a cost. Now, I want to go through, since I'm an engineer, so I wanted to see some system working on this. Now I'm going to try to show you some example, a worked example from the beginning to the end. So I wanted to explain what's the trade-off, how explainable, how performing I am. They are in a trade-off. And this trade-off is analogous to what information theory calls the rate distortion curve for lossy compression. There's no need to understand the term. You may have only a look at what it is down there. approximately it looks like, okay, I have a JPEG compression of your logo, and I constrain the amount of bytes needed, and so that it decreases, you see, from 22 kilobytes to slightly more than 2 kilobytes. And you see that I'm decreasing, so I'm compressing. The rate, what technicians call the rate, is reduced. And you see that the distortion is increased. You see the quality of the image is reduced. And this is a trade-off, and we are mostly used to that. It is quite widespread in technology. I think it is a clever way of doing that, of course. And this is more or less the trajectory we will take. And to make my example, I will resort to one of the most typical challenges for AI, which was put forward by Zalando. It is not a joke. These are images provided by Zalando, the origin. It is called the MNIST database, fashion MNIST, because it has images of 10 kinds of garments in general. So they are or t-shirts or tops or trousers. I'm missing an S in number one, sorry. Pullover, dress coat, sandal, shirt, sneaker, bag, ankle boot. They are very small images because they are just 28 to 28. But Zalando was so kind to provide us with 70,000 images that we can split in 60,000 that we can provide to our machine for training, and the rest for testing. So we can be sure that we assess the performance quite in a good way. This may seem a very trivial task, but if you have a look at this, would you classify it like a t-shirt or top or a shirt? Who knows? I mean, this is uncertain. And so errors are there even for human beings, not only for AI. So accuracy is a technical term that says, this is the probability that I have to absolutely have the right classification. So a sandal, if it is a sandal, a t-shirt, if it is a t-shirt, and so on. So of course, I would like to have 100% accuracy, but examples like this immediately show that it is not possible in general. So state of the art, there's a site, this is such a famous benchmark that there's a site recording the advancement of technology on this benchmark. And the absolute state of the art is has been updated probably 1 year ago. And it is an accuracy of, you say, 97%. It is considered good if I have an accuracy of approximately 90% because I behave more or less like a not extremely focused human being. Let's say that schemes just like the image like this. And of course, if I do blind guessing, since I have 10 classes, so if I simply random guess, I have 10% of probability of hitting the right classification. So blind guessing is 10%, and this is the bottom. You cannot do less than this. If you're doing less than this, you're doing something incredibly wrong. Okay, this is the conclusion. Then I will explain how I got this. And this is the curve that highlights the trade-off between explainability and performance. On the vertical axis, I have the accuracy, and you see that I have designed, I'm sorry, I didn't okay, no. I have designed a neural network. I will present it after. I have designed a neural network with 90% accuracy, so quite good, not exceptional, but quite good. And then I begin forcing this network to be explained. So I simplify it so that I can understand what it does. And the more I explain it, the less it performs. Now, what you see there is a region, actually, because there are no such a thing as a repeatable neural network. Every time you train one, you get a different beast. Okay, so this is the result of a population of 5,000 networks. And what you find in the darker plot is the median of the results, but you see that everything between the first and the 99th percentile is going the same trend. So you see, it's true, it has a trade-off. The more you ask for explainability, the more you lose in performance, and you may lose extremely you may lose completely your performance if you ask a complete explainability, because it goes down approximately 10%. So it means this is random guessing. So I know exactly what you're doing, but you are random guessing. Please.
Thank you. This operation of simplifying, doesn't it also imply some kind of value judgment by the engineer? What is comprehensible to a human and what is...
You're making great answers. Just wait 2 minutes and I will exactly show what this simplify for explainability means in this case, of course. And this is a critical point, just to be clear, because this is the result of an experiment, and in the setting of an experiment, deciding what is explainable and how I'm explaining is fundamental, because I cannot use for sure bullet number 2 just in words. I have to give it a mathematical formulation, and we will give it, okay? You switched off every time? Okay.
My question is that what is 129%?
Okay, this is a population of networks. So this means that 99% of the networks I have tried stays below this, and 99% stays above this, so only 1% stays below, and this is the median. So it's a kind of average, but it is more immune to noise, because when I'm making a lot of experiments, everything is noisy. So you will find this is a result of a Monte Carlo. It is a way of looking at the average behavior, the dark line, and then giving an idea of the spread around this.
Yeah, can I just make a quick question? But then if you have to use the good and explainable, so it means that there are some good and explainable networks. But you cannot discriminate. So you don't know why.
No, I don't know why they're slightly better than others, but you may also see that nobody goes. Let's go to the far right. Nothing is more than 30%, and this is quite a poor performance. So you may accept something that which is around 90, 80, but once you go lower, this is of course quite a useless AI. Thank you very much. Very, very focused questions. I hope everything will be answered in a minute. Not everything, but at least something. Okay, what I did was, okay, starting with and designing an AI, a true AI. And I took one of the first convolutional neural networks, which is called ELENet. It was proposed by Yann LeCun, which is one of the gurus of AI, before the quite famous AlexNet that actually was the breakthrough in superhuman performance in image recognition. This is just one step before. And the reason is that my task is extremely simple. Okay, it's a simple benchmark. The only thing that is important here is that every rectangle you see is a bunch of neurons, and there are connections between the arrays of rectangles you see. And the other important thing is that these neural networks accept the images from this side and produce a classification on the last side, okay? And it is approximately split in 2 parts. There's a first set of layers. Layers are these set of neurons that are connected with each other. A first set of neurons, which is the convolutional set of neurons. This is almost universally accepted to be something that extracts features from the image. A feature of an image may be, for example, how many black pixels are in there. This is a feature, okay? Or how many times my figure, the image, crosses a horizontal line or something like this. I'm not choosing them. The AI is choosing the feature, but actually what comes out from the first part of the neural network is a characterization of the image. There's no thinking there. It is almost universally accepted that thinking, so reasoning, so classification happens in the second part, what I call the brain, okay? And that brain is what is completely unstructured. So I have this bunch of neurons with every possible connections within them, between them. So that's the thing I have to explain. To be completely honest, I made some optimization on this. So please.
It's just a clarification. So you say there's this feature extraction. Who told the layer of the NVIDIA neuron to look for a feature?
Nobody, the training.
But it's been trained to do this.
Yeah.
So there has been some instruction.
Trained with the usual way. So it has been shown image, right classification, image, right classification. And starting from the pairs of examples of good behavior, there's an algorithm that is the training algorithm that succeeded in establishing all the parameters of the feature extractions, of feature extraction and the parameters of the brain. But the main point here is that the feature extraction part has a structure.
Sure.
Okay.
And that's
so we can understand it.
But that is based on experience.
Yes.
From before.
Yes.
And experience is built on some input from humans.
Yes, you see it from here. I'm sorry that it is written like this. You see that from the first bunch of examples before the plus is the bunch of examples I use for training. And then to evaluate performance, I completely forget about those. And to make it fair, shall I switch it again or not? Okay. And to make it a fair comparison, I completely forget about the samples with which I have trained the network, and I test it on a different set to be sure that there's some intelligence really going on here, some generalization capability. I'm not asking to repeat the same lesson. Okay. I'm showing different examples.
Just one thing, if I understand well, so you have just to respond to maybe what the designer does is to identify clusters of neurons, this in the convolution. Yes. And the function of the clusters is to identify features, but the designer does not know what feature the cluster is going to identify. It's just the assumption that information is going to be near in the image the information that is relevant to build to identify a feature, and therefore, am I right?
Perfect.
Yeah.
Perfect. The key point for our talk here is that the feature extraction part is not an unexplainable part, because we know how it works, more or less, of course. While since the brain has no structure, only parameters, only connection, only what we call fully connected layers, then here is the problem of explainability, because I really don't know what's happening there, because I see only a matrix of numbers, many of them, and I don't know what the function is. So I was telling you that I made some optimization. So I tried to find the shape of the brain that is the minimum possible to achieve 90% accuracy, okay? Because this is something that has to be done every time you make some optimization of the machine. So my machine is the minimum possible achieving 90% accuracy. Then this is exactly what I was anticipating. I don't care about the explainable part, because the feature extraction can be called a filter. It's something that engineers use since decades. There's no problem. It is approximately a filter. I can cope with this. The problem is, what is the brain doing out there? Okay, so my explainability effort will be devoted to the brain, and especially to the largest part of the brain, which is the one going from the features, which are the last features are here. Before that, there's feature extraction and the first layer of the brain. Why I am doing so? Because the features are, if you look into the specification that Jan LeCun gave, are made of 400 numbers. Okay, and then the brain begins, and it has 3 layers of 10 neurons. This means that the first part of the brain has to digest 400 numbers and translate them into 10 numbers. And then it processes it further and so on. And this processing is defined, despite the fact that it may seem maybe simple as only 500 numbers into 10, it is defined by 4,000 numbers. Okay, so I have to interpret how these 4,000 numbers make the computation like. And the problem can be solved without the mathematics from the geometrical point of view. And this is to answer your question more or less. So I have to take this unstructured mapping from 400 numbers to 10 numbers into a shape that I can understand more or less. Now, think of this processing as mapping points to points. You know that when I have an array of number, I can use every number as a coordinate and put it on a space. Of course, I cannot make the drawing of a 400-dimensional space, and not even of a 10-dimensional space. So my examples will be between a 3-dimensional space and a 2-dimensional space. In any case, let's say that this point here is the input, so the collection of all the features, and my first layer of the brain has to produce the first computation. Okay, which is only 2 numbers, so a coordinate that identify a point on a plane. There are many ways of doing this, of course. And who decides how I'm doing this is the set of 4,000 parameters that define the layer. Okay, so there are many points, and many points can be translated, because every time I put an image, and at the input, I get different features, and I have different processing in the brain. Okay, this may seem an impossible task, because nobody will understand what's happening, because all these points will be crossing the path and so on. But I can change my point of view. So you know that the coordinates can be taken with respect to different system of reference, right? And so the same point may have different coordinates with respect to different system of reference. And so, and you have to believe me, I can choose very special reference system. And if I do so, the same points, the one that from the left goes to the right, has a very simple writing in terms of coordinates. Because, for example, if instead of using the coordinates in the blue reference system, I use the coordinates in the red reference system, then the first coordinate in the red reference system goes to the first coordinate on the right, on the red reference system, the second to the second, the third to the third, and so on. There's no mixing between the processing. So everything is decoupled. I can have a look and have a list of the feature, and this feature looked at into the right reference system goes into that quantity. That feature goes separately from all the other into another quantity, and so on. And since I have 400 on the left and 10 to the right, some feature will go nowhere, of course, because everything is separated, and there are 400 on the left, 10 on the right. Okay. Now, if I want to explain things in a very good way, I have to limit the amount of paths that go from left to right. I have to limit the number of coordinates that I really consider in bringing the information from the features to the brain. So the more coordinates I discard, the closer I get to a human understandable explanation of this kind. Assume that I have, for example, only 2 features. It may be that I read this and I see that this feature goes into that concept, this feature goes into that concept, and nothing else. Considering these features that are the output of the first layer, the first feature is twice as important as the second because the number I'm multiplying is double. Or when I have to decide for a hat, the output. Or if I have to decide for a t-shirt, then there's a third feature that is exactly what I want to examine. Because I changed my system of reference, and everything is much simpler to say because every feature goes into a concept and so on. Of course, this is not a completely formal explanation. There's a name for this. This is called singular value decomposition, but we don't need it. The only thing that we have to understand is that when I was spanning the axis of explainability, I was just trying to keep as few coordinates as possible because it's very easy to explain to somebody, this is multiplied by 2 and affects this. This is multiplied by 0.1, it affects this directly without any mixing between coordinates. And so if I had to reveal what's on the axis of the horizontal axis that I before called the explainability, the simplification I gave for explainability, this is actually the number of don't care coordinates. So when I go to the far right, I have only one coordinate, one feature that matters and explains all. Actually, it doesn't explain anything because my AI is terrible. While when I am, for example, just one dropped coordinate, I still have 9 features that matters. Then I have 8 features to look at. Then I have 7 features to look at, and so on. And you see that when I write my explanation using less feature, the performance degrades. In doing so, the complexity of the network doesn't change. It is just the way I look at it. Okay. Now, what do I have to do now? Of course, I want to know more about this curve, and I will have, and this is more for me, but I would really like somebody to interact on this. I will have 2 approaches available: a data-driven one, and I will for sure pursue this generalization of this. And this means I will select a task, design a network, then I will have to decide for some model, mathematical model of explaining, which is the one that we were discussing before with your colleague. So some way of saying this is more explained than this, and I have some alternatives in mind. The first one I tried is the singular value decomposition, and then I will make a Monte Carlo simulation of a lot of AIs and see how they behave once I require that they're more and more explainable. And then there's another approach I will try, hopefully in the future, much more difficult, which is about theory. And I want to revive the fact that I was mentioning rate distortion theory, and I will try to map everything we know about neural networks into rate distortion theory and use that. Still, assuming that I did something good on the experimental side, there are a lot of questions I can make myself and to you about this curve. And I tried to put some of them on the picture. The first, of course, is what's the maximum tolerable loss, because this implicitly say what's the maximum explainability I can require, of course. But even going to the right-hand side and say, what's the minimum performance when everything explained, do I still have something out from the AI or not? And then there are more technical questions that can be extremely interesting. Is this curve convex or concave? This may be important because it's a completely different approach to how the trade-off goes. I don't know. These are questions to which my answer is still I don't know. I would like to know. So I will go to the second and last part of the talk, which is connected to this. You will see it in a minute. And it is also connected to probably the question you were making before about superhuman AIs. Sometimes unexplainability may be a goal. And these are some trivialities, not because they are really trivial, but because sometimes it's true that these are immediate argument. Some AIs have always been designed to be superhuman. Probably the most well-known are the 3 bullets I'm saying there, and I'm listing there. The first program able to beat at chess, the world champion, the image recognition AlexNet of 2012, which is the first deep convolutional neural network having something to say against in the competition with humans. And then a very well-known network, which is called AlphaGo, AlphaZero Go, playing Go better than the world champion of Go and so on. And the problem is exactly what I think was more or less envisioned by your colleague, saying, okay, but if we explain that, and if they were superhuman, of course, since the explanation is human, I'm losing the superhuman performance, right? Yes. And this is exactly what I want to show you, that there are applications in which the superhuman thing is important. And my application will not be chess, image recognition, and Go, you will see. This, what I'm developing here, has to do with the fact, what's the maximum tolerance I can have on the left-hand part? Because if I really want superhuman, the maximum tolerance is what brings me down to human level. Okay, and sometimes I don't want.
I would like to ask this because it sounds so intuitive that superhuman features are stuff that is beyond humans, that I'm wondering if that's really true, because I could imagine if we let an AI play a computer game and it just has superhuman reflexes, that's something I can understand. I could not replicate, but I can understand what it's doing. And I remember one example of reinforcement learning where I saw 2 teams of AI agents, 2 teams of reinforcement learning agents playing hide and seek against each other in a room. And as you went through millions of iterations, they developed more and more sophisticated techniques where one group of agents would block access to a room so the other group couldn't find them. And then the seeker group would put up a ramp against the wall and jump over it. I'm like, okay, these are like super smart, creative, emergent behaviors, but they were understandable just from observing them.
Yes, but they were not superhuman, so they were not doing something that you couldn't have done as a human being, right?
No, that not, but I think if there's something, for example, that requires, for example, super precise timing, right, or super precise reflexes that may be superhuman, but still understandable.
Right, yes. Here I'm focusing on something that's a superhuman performance in the cognitive. Okay, so in cognitive tasks, so tasks in which we presume to be the best in the world. Okay, so we limit to this. Oh, sorry, did you do that? Oh, thank you. If you limit to this, of course, lightning fast reflexes do not matter. Okay, so if let's limit to cognitive tasks, and we presume to be the best at all.
Cognitive task, the cognitive task that is needed in inventing, for instance, a mathematical proof, is different from the cognitive skill that is needed for understanding.
Yes,
so
yes, of course.
Even if we are not as performing in inventing.
Yes, whenever you qualify the performance of something, you have to define the game you are playing before, of course. And this is why, just give me a minute. This is why I want to mention exactly what they were playing at. And this is why I want to make a very precise example in the next slides, because AI are not superhuman in general, of course. They can be narrowed down to make something very, very well. And this can be of our interest, I think.
I was just wondering if we could briefly go back to the features and the brain, because I was wondering, when we talk about explainable AI in as non-technical people, maybe we do look at the feature stage and not necessarily at the brain stage, right? Because there's been a couple of examples. I read some articles, one on the where an AI was looking for COVID in lung pictures, and it turned out that it had basically just been reading that the things that came from Bergamo, they all had COVID, and the things that came from elsewhere, and that's basically the feature. It
Right.
just looked at a different
Yeah.
part of the picture, right?
Yes, you're perfectly right. Again, a very clever question. Let me go back to this, which for me is a fundamental thing, as I'm explaining things following point 2, bullet 2. So I have to give you a model that doesn't work only on one instance on a precise thing, but I have to convince you that what I'm doing in general is right. Okay, so true. Most of the effort we are doing right now is explaining how certain features of the input, images, time series, or whatever, affect the output. And in this sense, yes, we are dealing with what is extracted in the feature extraction layer. Actually, what we do is beginning from the end, going through the brain, assuming that the brain decides for the best, and going through the feature extraction to identify the structure. That's true. And in fact, we can explain them. What we cannot explain is how the features are combined for complex tasks. So what we cannot do is to give you an alternative model that you can communicate to your neighbor and see it more or less does though.
Would there be a way to look at an AI who is looking at pictures, for example, and let us know what it's looking at without going into the brain, just going at the features? Would there be a way to say this is explainable AI because we know at least what it's looking at? It's the same as for example, people doing samples, right? I want to know who you asked and what you asked them.
Bullet number 1, bullet number 2 is different. I mean, giving example is not explaining, it's convincing. So the problem is that we have to explain how it works, because let's say that I have a judgment, I have a decision from a judge, okay? And what you see there is something that it is a chaining of logical arguments. And when you see them, you immediately think, okay, I will keep it, I will use it in another case, right? Okay, so the main point here is that what we perceive as a true, very big, strong explanation is an alternative mechanism that we can reapply. So it is for sure that I can know what the AI was looking at, but can I decide that in the next input it looks at the same point? So this is the difference. This is what I'm looking at, the true explanation.
I'm just wondering if when we talk about explainable AI in a legal setting, for example, if that's what we mean, like, do we want to explain things to that extent? Because if you think about a human judge, for example, you know what he looked at because he wrote it down, but you don't know what's going on in his head. Humans are annoying like that, right? Mm-hmm. So
right. So what you're saying is that not every explainability issue has to do with my definition of explainability. Right. Perfect. I completely agree with this. Still, since I want to frame down some generic and some general trend, okay, I need some kind of definition. So probably there's no such a thing as there's not such a strong trade-off if you lower your expectation in explainability. Probably, I don't know, because I haven't studied it, of course. And I know I'm rising quite a lot the bar of explainability because I want an alternative model. Right, perfectly conscious of this. And it may be that the curves you are seeing here are completely different if you change the definition of explainability. Right. You have a question?
Yeah, it's so it seems to me, so I understand the message, Riccardo, that there is a trade-off between accuracy or efficiency and explainability or accountability, whatever the words we use. But is the progress you are seeing technological developments making this trade-off less acute. So is there a way we can actually improve on the, making this not a trade-off in the end? It might just be that we're in the early stages and we are going to get there. Or is this trade-off like
Terribly
permanence? And
yes, you're absolutely right in asking. That's probably this is a key question. Okay, because if we accept the trade-off, we want how to transform the curve we have seen, right? I have to say that to know that, I have to go the right-hand side of this slide, because I cannot make any really only data-driven approach. My feeling, but this is just my feeling, is that since I believe that this mapping between explainability, performance trade-off, and rate distortion trade-off, okay, since the other one is a universal statement, let's say, something that cannot be absent, I think that the trade-off will be there in any case. Of course, this doesn't answer your question. So I don't know how the curve will be modified by technology. I will bet that the curve will be with a negative slope in any case. Okay, I don't know how much. And I would also like to know whether it is concave or convex, probably. Yes. And this is something I don't know. This is why I put on this slide two approaches, because I don't think that data-driven approach can give me all the answers. Yes, I can improve the amount of data, get more complicated AI, design something which is after a more thorough architectural search. So there are a lot of things to be done on the data-driven approach, but the answers to these very important questions, I think they can come only from the theoretical studying that I have not done.
Riccardo, I have a question. Since we are somehow derailing your presentation in a way that
I'm really happy with this.
So now my question, if you go back to your famous picture, right?
The famous picture.
Here you are. So
the one with the questions.
Exactly. Is the confidence interval, the shape of the confidence interval qualitatively general, meaning that you have a larger spread in the medians?
Yes. I mean, nothing universal. I have other populations of other networks that were designed. When I choose what I have chosen this is the minimum brain performing the task up to the desired level at the far left. Okay. I have others, and they behave like this.
Because this is interesting, because there is a third dimension. So you have accuracy, you have explainability, then you have variability or precision of the outcome, which once we think about the decision making, that is application of AI tools, it's quite an important element, right? So if you think a policymaker who has to take a decision, the variability in the approach is in the decision process is quite important element, right?
Right. So there is. I didn't think about it, and that's wonderful to think. And the reason why I made this was mainly to be sure that I had a definite a definite loss of performance at the end.
Okay.
Because I didn't want the spread to be so large that some of them was still able to behave like at the beginning. Okay. So I wanted to check this. And I have to say that, yes, the spread is maximum at the center. Actually, yes. I don't know whether I have others. I will check whether I have others plots, but I'm pretty sure that I cannot say at the center that's the problem, but not at the beginning for sure. Okay, so what I want to do is to show something in which having a superhuman, let's say, performance is absolutely likable. And if I do something like explaining something, I find myself introducing another AI, which is unexplainable and so on. Okay. To do so, I have to deal with some technical details, which is compression and efficient sensing. And to explain this, I will rely on Sudoku. Okay, this is a paradigm to explain the role of some actors in the compression game. Okay, everybody's familiar with Sudoku, I think. Okay, let me rephrase it. Okay, I have a grid of numbers, but I'm not giving it to you. What I'm giving to you are some clues that is a subset of the numbers. And then you recover that, the original one, because you know that there are some rules. And the rules in this case are no number repeats in the same square row and column. Okay. And so you may think that I have 81 numbers in the scheme, but I have just given you 40 numbers in the scheme. So I have made a compression. This is zipping. Okay. And your solving of the Sudoku is unzipping because you retrieve the original file, the original whatever, the original grid of numbers. And the main role here is the one of the rules. The rules that are called in compression terms are called priors, because it's something that I know before ever even looking at the scheme. I already know what the rules are. So they're given prior to everything else. So just let me make one step further. Let me alter the rules of Sudoku, and let's play Sudoku star. Sudoku stars as the rules slightly changed because it admits only one repetition in at most one row, columns, and square. Okay. This means that if I give you the clues, you're no longer able to reconstruct perfectly what was the grade, the original grade, but you may make some mistakes. Okay. One mistake, of course. Again, this is a prior. This is not useless. This is not useless because you can reconstruct most of the original numbers and you're making one mistake. Okay. This is not zipping and unzipping. This is called lossy compression, because when you compress it, you cannot retrieve perfectly the signal, the grid that you had before. So you have lost something. Some information is lost. Then let's change the Sudoku into gray levels. And if I pretend that my Sudoku grid is an image, what you're doing is actually sampling the image only on some pixels. And starting from those pixels, you can reconstruct the original image. And you have to know the rules of the Sudoku for the images you are using, you are dealing with. And if you know them, you may make small number of errors possibly. In this case, since it was Sudoku star, I made only one mistake. The rest of the image has been reconstructed perfectly. Then I acquired only few pixels, only 40 up to 81. This is called compressed sensing, because this is an acquisition of pixels from an image, but it is not of the whole image. And subsampling may be speed up. I'm pretty sure that you know that MRI is a time-consuming operations, and the more it takes, the worse it is, because the patient is moving. So I'm gathering information also on his breathing rhythm and so on, while I would have to have a completely static image of what's inside the patient, right? So the faster I can go, the better it is. The problem is, what are the rules of Sudoku MRI? Nobody knows, okay? My aim is I acquire the smallest possible subset of pixels, and then I will reconstruct the image exploiting the Sudoku MRI rules. But regrettably, I don't know the Sudoku MRI rules. But there's somebody that can learn the Sudoku MRI rules, which is an AI. And this is a scheme that I can employ. Okay, now this is very engineering. I know, block schemes with arrows going around. Okay, let's go. There's a patient there on the left, and then let's focus on the upper path. Okay, that's the conventional one. If I don't do anything, this is how MRI works. There's something which is called K-space sampling. The key word here is sampling. Okay, there's a space of pixels. They're not pixels actually, and I sample all of them. I can take all of them. I have to take all of them. Then I make some inverse Fourier transform. I don't care. But starting from the full sampling, I get my image. Okay. Now I want to make it subsampling, means I don't want to take all the elements of the K-space. And if I do so, of course, I come up with this, which is not a good image, because when a doctor looks at it, it says, okay, that's rubbish. Okay, so what I do is pretend to do the classical thing, pretend to do the subsampled thing, and then make, not me, but an AI compare the two and learn what's the difference between the two. So that next time when I see the blurred one, I'm able to add the corrections to make the more needed one. And this is exactly what happens. If I do proper training, there are architectures doing this. If I do proper training, what I obtain is this. Now I can skip completely the conventional path. I only subsample the case space. I make all my processing, I get the bad image, then I ask the AI, give me the corrections, I apply the correction, and I get back the original, the good image. Then somebody with a fixation for explainability comes in and says, no, I want to know how you do it. Okay. So what happens is that since nobody knows the rules of MRI, of Sudoku MRI, if I expect that the AI explains them to me, it performs suboptimally. So what comes out is this. I have the lower path that does exactly as before, with the exception that here I have explained things. And so the result of correction is suboptimal. What would you do? I would do the same as before. Ask somebody else to correct my errors, of course. And since no humans can do that, I will do that. The AI will do, the alternative intelligence will do it. So again, the classical path up there, a lot of patients analyzed, and then I will come up to the not so bad, but not so good image here in the middle, and I will make the AI compare the two and learn how to correct. And this works, of course. Then I have an explainable AI making some part of the job, and then I have an unexplainable AI making some part of the job. And guess what? We have trained also the second AI that is not explainable. I can make it explainable, of course. But since I'm in the larger part here, and I don't want to tolerate a lot of loss of performance because I want to have a very focused and very neat image, of course, if I add explainability, I will lose performance. And if I want maximum performance, I will add another AI, which is unexplainable or not. So you see that not in this case, this hasn't to be explainable. And this is not a trivial example because the medical doctors that will look at these images will ask you, how did you get them? For sure. And there's a reason, because every medical doctor that looks at them has become acquainted with the kind of errors introduced by standard machines. Okay. And so they want to make it compare with the standard flow. And you can't simply, but you know, by performing a lot of experiments, that the image produced by the AI, by the unexplainable one, are better than that of the explainable one. So you will come at a problem here with the medical doctor. Okay, let me come to the conclusion to this. I would like to think about AI as an alternative intelligence, and I would like to think about explanation as a translation between, let's say, two minds, two ways of thinking, just a translation. And everything is always lost in translation, right? And what is lost here, that I have a cost, I may lose in performance, I may deviate from my original goal. And there's an explainability performance trade-off. And it is not the only place in which I have a trade-off in my life, of course. There's always a trade-off somewhere. Healing and side effect of drugs, for example. But also the benefit and the threat of setting a maximum car speed. If I didn't want that cars killed any human, the maximum speed would be 20 kilometers per hour. Nobody will use a car probably, and we wouldn't have the benefit, the social benefit of mobility by car. And I personally think that this is a trade-off that I cannot understand alone, and probably you cannot understand alone. And in saying this, I'm saying social scientists and people in technology. And I think that this must be analyzed together. In fact, what if, for example, an explainable AI outperforms human in recruiting, assigning employees in a public administration? So there's a guy that got his promotion denied for some reason, and I cannot explain it. But I know that the public administration that benefits the society is optimized in that way. Would you accept it or not? I don't know. These are questions for which I don't have any answer. And of course, I'm almost asking the answers to you. Of course, what happens if an unexplainable AI is much better than medical doctors in diagnosing difficult pathologies, on choosing therapies that have trade-offs because they have risks, or driving vehicles that may still cause damages? They are better than us, but still, they must be explainable because we want to know how the accident happened, right? Okay, this introduces to the last slide. or transparency. Okay, it seems that what they can be designed to be superhuman in is addressing some sort of difficult trade-off. Try to keep this in the back of your mind, because now, of course, I want to make advertising about the need for knowing the technical trade-off between explainability and so on. Let's say that, for example, explainability and performance can be put together on a function that gives me the real value of my machine, of my technique, okay? And assume that, I mean, I made it increase in both directions. It's trivial, I know. But of course, if I know the technical trade-off curve, I may find the optimum for this, assuming there is one. But assuming there's no such a simple curve, of course, this is an optimization. This is again a trade-off. So you may instruct an AI in finding the right way of addressing the compromise between explainability and performance, given an appreciation of the social value of what comes out, of course. Okay. And this is my fast forward. Have you ever heard of exception? Never seen on. This came out in my search for alternative intelligence keyword somewhere. And I hope. I wanted to show you this because I think it summarizes everything that I'm thinking about this in these weeks. Okay. And again, another appearance of alternative intelligence in this case in science fiction, but it is quite a good series. You should. Okay. Thank you.
Thanks a lot, Riccardo. This is really a great presentation, really in the spirit of the type of meeting that we are having here. So that's really excellent. So let's open the floor for discussion. I guess there will be questions. Can you also check online if okay, so let's start with Philip. Yeah.
Sure, yes, I want to second what Giacomo said. That was really good input, very, very useful. One thing that I was wondering, one of the last things that you showed, this two-step approach where an explainable AI is supported by an unexplainable AI. Is this just like shadow play, or is there some actual value in having a first step that can be explained that is then enhanced by a second step that cannot be explained?
To be fair, this is okay. To be fair, I would say that altogether we have to decide whether there's any added value in having something explained. I mean, most of the processing is explainable, and the rest, the last mile, is not explainable, but we need the performance. I think this is part of the trade-off. I mean, it's not formalized by the curve. From the technological point of view, as I see it, there's no need for the explainable part, because the very end is what I want.
But does it just not add any value, or are there actively errors introduced by having this first explainable AI run over it?
Yes, that's interesting, because I had a brief discussion with Nino Rotolo about this, because I had the opportunity of showing the preliminary result of this, actually not even results, but in a meeting dealing with the Partenariato Esteso #1, which is on the Italian project on AI, funded by the Recovery Fund, the European Recovery Fund. And the observation of this colleague of mine at the University of Bologna was, yes, it is not useful because you have understood something. Okay, you have learned at least some of the Sudoku MRI rules. So this is something that goes into the knowledge of humanity. Okay, so he saw some added value in this. At least they were just like they learned something, and they were trying, the AI are learning something for us, and they're transferring part of their knowledge. I know it's terrible to say this, part of their knowledge to us human beings. So that was the point of Nino. So at least we have understood something more about MRI. I don't know. I think it is implicitly in the trade-off we all together have to address, because it's a cost. I didn't want to emphasize this, but to have 2 blocks instead of 1 is a cost. I don't know what kind of cost, but it is a cost. There are just 2 systems instead of 1.
Just a point on this, but you may also have downgrading the performance now, because in the first stage something may be lost. So it's not just something that is don't adjust to pay for more computer. No, maybe I don't know.
I think that if this goes, the final result should be the optimal one. Okay, and I think that the spirit of the thing is decide whether at least part of this should be explained because you feel more comfortable with this, and leave the last details to something that you don't really understand. If this is acceptable or even preferred, why not? But it's a cost.
There's also a question online.
Oh, thank you.
Considering the explainable AI, could you speak some considerations about fairness, accountability, and its use by tax authorities to audit taxpayers, for example? And then Tiago raised his hand online, so maybe we can give him the floor. And then there's a person who raised their hand, so maybe we can give them the floor after you
Okay, okay. So, so fairness and all the rest. I mean, no, I prefer the problem here with fairness and all the rest. Keep in mind that you're asking this to an engineer. Okay, I don't know whether they are looking at me or not. No. Okay, hey, I'm here. Okay. So the first thing I have to do to answer this is to have, let's say, a quantitative model of fairness, accountability, and so on. And this is the main problem. I have to say that with Giovanni, we had some research together on the fairness concept and on the various definitions of the fairness in classification, starting from some very formal definitions. And you can say something about that by making some considerations that are actually formal or at least quantitative. But it is very difficult to summarize them in a few minutes, because every time you ask an engineer to speak on a certain topic, they immediately think about how can I model this in a mathematical and quantitative way. And I don't have for example, a quantitative model for fairness or accountability and so on. So I'm afraid I cannot answer this question. Don't know whether it's, I know it's disappointing, but ask for somebody that doesn't make the machines work.
One more thing. So today I was reading about new AI models that were brought online or talked about by Aleph Alpha, the European AI startup, and they had like a very big line of products into transparency and explainability of AI, and that's really always how they try to distinguish themselves from other American products. And they said, well, we have a GPT model that can point exactly to where in the sources it takes particular information from and which other information conflicts with it. And now they say, okay, we have this other AI, which is usually not used for consumers, but more like by industry or public administration, where we now have a control version that performs just as well as all the other models, but that is fully explainable. Would you say, based on what you've shown us today, that's probably just marketing, or could it be that they actually managed to push the frontier of the curve, produce something that's better, perhaps not as good as it could have been if they had left out the explainability part, but still something?
I don't know whether, sorry, it's a good question, even this. I'm enthusiastic about the questions I'm receiving. And you can probably, we don't know whether they have succeeded in pushing the curve lower, for example, right? But for sure, they may have only decided to find another operating point in which they incur more cost, and then trying to make you know that they're incurring in those costs, so their product is bought by many people. I mean, so okay, I'm explainable, okay? So you should prefer me, and I will gain to recover the costs. that I'm incurring to be explainable, probably. It depends on what kind of, if the costs are only loss of performance, of course, there's little to do, but nobody will tell you exactly what the performance of a large language model is. It's a very difficult. There are specialized databases to perform some specific tasks and rank the models, but they're very few. So it's impossible to say if one large language model is better than the other. So that's a quite obscure point. But I can figure out something like this. Okay, we are on the curve. Everybody wants to stay there and they're selling the product there. Then I'm explainable. So I'm performing slightly less, but I'm telling you I'm explainable. So if you like that, you pay me and I will recover the cost, or you will tolerate the loss in performance. It is something that probably people from Anthropic are doing. Do you know them? Yes. So the language model is called Claude, right? And they are strongly advertising the fact that they're totally innocuous, let's say. So they're gentle, kind, completely affordable, completely reliable large language model. And to be honest, I've tried it, but for example, they don't have an API, so they cannot be used to, so they're taking things out from other places. So what I see out there seems to confirm from other points of view that the curve is there. And everybody is positioning in the places it prefers, probably. In any case, I would really like to have the pointer to what you said, because I didn't know it.
Yeah, go ahead.
Tiago, please go ahead.
Yeah, thank you very much. So I see that we don't want to talk about fairness and normative aspects of research, which is quite okay. Like also, I understand that you're an engineer, so I will try not to push you in that direction. Although it's a bit weird to me as a sociologist, but there's something to. So let's, for the sake of this discussion, reduce our whole argument to optimal results, as you're doing, like all about optimality. And so the trade-off is between optimality and explainability. But the question is, there is a flow of power dynamics associated with optimality, because optimality is not like X and Y's. And as you have shown yourself in your graph, like the slope can be not just just a line that goes from up there to down there on the far right, but there are many ways which we can understand optimality, right? So let's go back to your example about like how someone gets promoted in a job or something like that. So we can based on the data and the models we get, we can predict that white men are the optimal result for getting funding for university. So we should promote white men for full professors. But then what does that tell us at a larger social impact? Because I think that Sudoku is crazy good, but like life is much more complex than this, and there are so many variables that come together and conflate what is that thing called optimality. So how do you reconcile these worries that are larger than your model when you put someone in the MRI and there are other things going on around it?
Okay, great. This is one of the reasons why I after many years of being an engineer, I began thinking of things that are slightly different from straight engineering, and I'm trying to cooperate with social scientists. And so thank you very much. You're perfectly right. Like every engineer does, I'm leaving out all the real life. And so let's speak about fairness. Okay, if you want me to address with my own tools, of course, I can tell you that once I had the opportunity, again, with Giovanni here, to have a look at the fairness definition from the mathematical point of view, and we realized that there are a lot of fairness definitions out there, and if you want to apply all of them simultaneously, you cannot satisfy them. Okay, so I recognize that my point of view is quite limited. In any case, the big point we're making is that optimality is not all, and I can perfectly realize and perfectly agree. the problem here, let me get the famous curve. Okay, is it still shared? You share. Okay. Basically, you say that I would like to lose some performance to satisfy the explainability. I may want to lose some performance to satisfy fairness, because even if I'm not explaining it to you, even if I explain it to you, I may be still favoring white males instead of any other group, subgroup, social subgroup or something. I think that the main task of this curve is identifying the problem, not solving it in this case. And it is not up to, let's say, engineers or technicians to establish what should be done with the curve. And so if somebody says that, okay, this is a private company, I want to hire whoever I want. And if I want to hire only white men, I can. I don't know if it's possible or not by the law. So, and this is why I know it's a big problem. And this is why, for example, I wanted to make my example quite slightly difficult to address in a straight way. And in making my example, I was I've chosen recruiting, assigning employees in a public administration, because this gives us the opportunity of seeing the other side. This is a public administration. So if you don't optimize it, you're damaging something else, which is the community. So now I'm reversing the question. What would you do if you knew that recruiting only white men would improve the efficiency of that public administration for the social wellness?
Can I go?
Yes, of course.
Yeah, okay, so this is the thing. It's like you're understanding optimality as just one or two things. But what if I tell you that, okay, you lose efficiency in the way the service works directly, but indirectly, you're giving opportunity to minorities that on the mid-run will, spur up education and bring diversity, and actually find that there are new problems that you never realized because you only had white men that carry with them like their privilege, and they don't realize what Black people go through when trying to get to social benefits. So you see, like, optimality, this is the problem I have with the talk, is that optimality is not one thing. It's so much more than one thing, and it reflects the power dynamics that are at play. And we're speaking like if they're just optimal results in which there's A against B. And so, yeah, then I return the question back to you. So what would you say if I tell you that there are variables that are omitted from your model, but yet you are not able to grasp because you're so focused on implementing an AI system? And what do we do about this right now?
Great, absolutely great. Yes, I understand that this discussion can go on forever, and I personally find very interesting. I'm so sorry that you're not here, because probably we could have half an hour past the talk to continue this.
Can I maybe also ask you something, just to
Yes, of
proceed a bit
course.
further? I think,
Tiago, I'm so sorry. You perfectly understand that we have to stop here, but again, if you want to interact with me after,
my flight
I will be very glad to do so.
Sorry for not being there. My flight was canceled. I will not take over more the session. Thank you very much, everyone.
Thanks.
I'm actually following up on your question, Tiago. So I think what Tiago was saying, for me, it's like clearly human rights. And this is the point. It's not just about explainability. It's not just about fairness. It's not just about, it's about everything. Accuracy too. So for me as a human rights lawyer, if you tell me, oh, well, I'm going to give you explainability, but I'm going to lose accuracy, this is not human rights compatible. So it's about putting all of the values together and find the optimal, because of course also human rights is optimization, clearly, and margin of appreciation. So it's about putting all of the values together and find the optimal, not just accuracy, explainability, right? So and I know it complicates things, but
it makes things impossible. This is why social scientists exist. Otherwise, engineers will be enough. No, this is exactly why I appreciate this kind of reasoning, because I know that whatever we do to make machines work is limited, because it's limited to machines, systems, applications, and so on. I have a quite clear awareness of this.
It's a follow-up of a follow-up. So if you move on one slide. Okay, so this is the economics handbook, page 15. This is something
zero.
This is something that you would find. So the economics profession exists because of trade-off. So we live on this exactly. So I think the discussion we had with the last two questions refers to the fact that you can enrich the value function on the left, adding other dimensions. Human rights, equality, efficiency of the system. Well, efficiency is already the performance, but you can add dimensions. You still can optimize. So, what I take up to this is a metaphor of the approach we should take up when we choose about explainability. Is one of the elements of our judgment. Now, the question is, the difficult point for me is that, as you at some point pointed out, if you keep adding all these things, you go nowhere essentially, no? Another issue that I see with this approach is that at some point you will have to implement, taking into account all these dimensions, and there is the political process, which is risky once you enter into these technical dimensions. It's essentially not a question to you. I don't have answers. It's just food for thought, and Giovanni maybe has some.
I think that maybe we are asking this is something also that I discussed in our joint work. We are putting together, I think, the prediction that the system makes and the decision that you can take based on that prediction. So you have a medical system that predicts the likelihood that a person has a certain kind of illness. Then what to do with this prediction for different kind of people having different revenues, whatever, is something that you can think about it separately. So I think that, so I don't think that it is necessary to put everything together into the outcome of the prediction made by the machine. This is one input to a decisional process where other things may also get into. And also you may consider different thresholds for one decision rather than for the other, given the, I think that, yes, this would be the way which I would suggest to move forward, have these kind of predictions, but included them in a larger decisional process where other inputs may be treated automatically, maybe not treated, that cannot be treated automatically, will go into. So if you have, for instance, in the job application, one, assuming that the system is really able to predict future job performance, this is one element to be taken into account. Then you may have also other elements. You may have constraints concerning the kind of representation of different groups on the population. And this would be a further element that will contribute to determine the final outcome.
Okay, that's a follow-up on the follow-up on the follow-up on the follow-up. And okay, so I really liked the main message of your talk. And in a way, I also like the fact that it's a bit uplifting in a conversation that's dominated by catastrophic arguments about AI. And so I think it's good to hear that there are also some, value to these systems, and they can help solve problems which are problems that politics cannot solve. So that's very good. At some point you said these trade-offs exist in relation to the speed limit for cars and the use of drugs for health treatments. And so I think that's helpful to recall. But then sometimes I feel like the engineering or technological community should actually help us build the next argument. And the next argument is to say that the trade-offs are not solved by one answer, which is explainability across the board. So in life-threatening areas like driving or use of drugs for medical condition, certain guardrails are in place. So you have second review by a doctor, you have safety belts, airbags, and stuff like this. In other areas in which you don't have, for instance, health risks, but other kinds of risks, the guardrails are different. So I think to me, the discussion is often hostage to extreme simplification that there's AI and there's explainability. And there's one trade-off, and it's the same in every context. So if we could build up some model in which we have a model of the world in which we have trade-offs that involve different contexts, different risks, and different responses, so that would help so much. And in a way, that would also allow us to redraw some boundaries. So you were saying, you know, hiring in public administration, discrimination is absolutely unlawful here. Hiring in the private sector, discrimination on hiring is almost not unlawful de facto because it's very hard to prove, right? And the state is not involved. So if a company wants to hire only male people, you know, it's bad from a public opinion perspective, but it's not unlawful. So we could actually redraw the boundaries here and say, if we use these AI systems in the public and private administration, we could actually improve on discrimination. And so I wonder how you see the role of, you know, in a way, it would help us a lot. If you could help us identify how these trade-offs diverge across sectors and contexts, and then help us think about the system that we can put in place to answer this. And, you know, if you know any work on this, that would be very helpful.
Let me start from the end. I don't know of any work even trying to formalize the trade-off. So we've been struggling with literature, trying to look in. I mean, there are a lot of papers, even from the technical community, hinting at the fact that everybody knows it is there. Everybody knows it is there. There's no doubt about it. The problem is formalizing. So that is the end of your question. Let me go to at the beginning. I would really like to follow your advice and being able to have a box with me. Inside the box, there's a trade-off for every possible application and setting. I know that would be wonderful. I want to be there. I want to be there, but regrettably, I'm still struggling. And it's, of course, it's for my lack of competence in this case. I'm still struggling with the basis of this. Okay, I've just seen the first curve in my lab, which is made like this, and I'm still asking whether it is concave or convex. I know it may seem as a strange thing, but probably Giacomo doesn't think it's a strange thing about convexity, because so I think that what you make is a good ending point of this kind of research. But regrettably, I've come here at the beginning of this research path. So I would really like to have the answers you're looking for, because I think that it is something we can provide to the social science community. It's something that can be achieved. I don't know in how long, so because the idea is to have a method, okay? Let's say a technically grounded method to establish, given the framework, the application, and the technical tools that you employ, what is the trade-off that you're facing. That would be nice, not to have a single curve, but a method to produce the curves. That would be nice, but not yet there, sorry.
Thank you. I have heard explainable AI referred to as a toolbox, as if it's something that comes in a number of different forms and shapes. And I was wondering if the thing that you're presenting here, which affects performance, if it's not just one of the tools, do we not have other tools that we might choose from in order to be able to explain, and also to follow up on the public administration thing? I think that one of the things that's happening right now is that we want to use AI not just for things where we know what the answer is, like not just to make perfect MRI pictures. We also wanted to use it for things where we're not entirely certain what the answer is, such as justice. So we already have applications of AI in criminal justice. They have something called the COMPAS system in the US, and there was a case on that, and the state won the case, but that's a bit weird to a lot of people who work on rights, because if you look at it, for example, they were not able to tell whether, or they wouldn't tell because of property rights, whether the system took gender into account or not. So if we look a bit on, I was wondering, I mean, it's not really what you've been researching, and maybe that's annoying for you, but this toolbox, what does it include other than investigating the brain and breaking it a little bit?
Okay, first of all, let me say that the idea of toolbox is very good, and it is exactly what is being pursued in most of the research that is being made in the technical field about. So it is quite clear that there's not a unique approach to explain something. For example, there are two main categories, which is the explainable by design and the explainable a posteriori, which is two main classes that have to be addressed separately. So I give you an AI that was not designed to be explainable. Can you squeeze out something about that or not? And design flows that guarantee that at the very end you get something which is explainable. And in both terms, in both subsets, there are a lot of tentatives, a lot of proposals, and they will more or less concretize at a certain point into toolboxes. And probably some of them will be certified. I see this as a probable outcome in the future, not even far future, I think in a few years. And I would really like that one of these one of the elements in this toolbox can be the method for squeezing out the curve about the trade-off. That would be nice. And probably it would be implicit in the fact that some of the tools in the toolbox will be more powerful than others. And you may immediately measure what happens when you apply one, when you apply the second, when you apply the third, and you take 3 points on this curve. So probably in an implicit way, this kind of analysis will be inside the toolbox. The problem of Compass, which is quite well known, and is that not only it is not explainable, but it's totally black box because it's owned by North Point, something like it's a society, it's a company owning it. And of course, it doesn't want to reveal the details because it's selling the services to the United States government or state. I don't know exactly what's the contract, but they're making money out of it. And so they don't want to make you look inside their machine. But explainability in this case has 2 layers. So probably Compass is explainable. The feeling I have is since it was designed 20 years ago, the kernel of Compass is 20 years ago, I feel that the basic is a linear combination of something. So something that we can, so the already changed in the reference system, everything has been done to explain it because it has been designed in a very elementary way. I think that most of their technology is then in the choice of coefficients so that it mimics the social relevance of what they are doing or the amount of outcome they want to have, the guilty or innocent or so on. So for them, I think that explainability is not the problem, it's the black box effect that it is the problem. For sure, if you add the black box effect on top of explainability, things get very hard because the only thing that you may have is something that analyzes the AI from input and output, keeping everything. So you cut in half the toolbox, only the a posteriori tools, that would be very, very difficult.
If I can just follow up on that. So one of the things I think I see from what I've seen so far is that in the field of law, there is a wish to include AI, but you don't necessarily want to include AI that's trained on the law that we already have, because we don't really believe that it is fair. It is full of biases. Humans are biased. We would like, if we would want to incorporate AI, it would be to make it faster, because all
efficiency,
all court systems, I don't think I have studied even one, are overworked and under budgeted, and they all have backlogs, and it works poorly. So that's one thing. Maybe we do the same justice, which is not perfect as we do now, but we do it faster. Or we want more justice, right? So we want the law to be applied as a Montesquieuan mouth of the law way, which doesn't incorporate human problems. And I think the way that Compass has sold itself is that it says, well, you know, if you're doing recidivism studies, you find out that it's much easier to get released on bail if you're white than if you're black. But if we have an AI that does it, we could give it only the information that we wanted to take into account. And the problem is, of course, that in real life that doesn't always work. So my question really is, if we give a machine only the things that we wanted to take into account. So for the public administration, we tell it only to look at the grades and the experience and all these things. We don't want it to look at what school they came from, because we know that that is already a part where bias in human society has interacted. Is it still an AI, or is it just computer programming? Like where does computer programming become AI? And does it make sense to talk of AI if we're not training on real life
this
data?
Conversation with the judge, which is the president of the family section of the Tribunale di Genova, and I think that this was one of the problem in the definition of AI, which is in the AI Act, because everything that is an algorithm deals with data and takes decision, helps decision, fits within that definition, which is very broad. And it is not even necessary that there's machine learning in this, no. So formally speaking, according to regulations, and I don't know how to say it, it is AI. But there's another thing that you may use this AI for, and you mentioned it, but I think it can be very interesting. It is not a linguistic AI in this case, but you can use for some purposes like repeatability of decisions, which is something that may affect the quality of justice in a huge way. And I personally have studied this problem for the quantification of maintenance alimony. So for maintenance for children in a separation, and Italy has no fixed way of computing this. Okay, and so every judge basically has a different path of the reasoning. And in this case, even an elementary program, let's say very trivial one that you would not classify as an AI, but it is an AI according to the AI Act, would be very, very beneficial, because if you move from town to town, you repeat the same case, and from judge to judge in the same town, they decide different things. There are small things that still impact the life of people, of course, because it is a very important step. And even in this case, I think that AI may be beneficial, not only for efficient, but for making decisions repeatable. That would be very nice in very narrow and focused occasions, probably.
I completely agree with you, but I think there the issue is that works when you have a repeated case law, but when you have a new element that can completely change the course, then there's error after error after error, right?
No.
So injustice after injustice. So I think this is the biggest, right, when it comes to judicial AI systems.
So you're saying that human beings are there to make all the juridical system evolve according to the new cases that are coming in.
I think this could be their place from now on, right?
Right.
If we use judicial AI systems, then we have
okay.
judges.
We're going very far from the original topic of the.
Sorry.
But think that technically it is possible to make an AI raise a flag when it sees something which is rarely present in the training set. Okay, technically it is possible, and there's a small branch of research also on this. I don't remember the references, but it is possible. I mean, during the training process, you may training something in parallel that does not learn how to solve your problem, simply learns how the data are structured from the statistical point of view. And once you stimulate the AI that you have trained to solve your problem with something that has not been used in training, the other one is still able to raise a flag. So if this mechanism can be put in practice, probably that would be enough to make a human take intervention and say, okay, this is a new case, let's say. It's a completely different thing. So stay away, I will decide, and then I will put my decision in your database and so on. Technically, it is possible, but I've not heard of things like this in any of them. But technically, it is possible.
Sorry, I know we're going over time, but there was one thing I read yesterday last week that made me think. And that was, it was said, anyone can create a large language model with stolen data. Today, I read that Japan made it completely legal to use any sort of copyrighted material for training AI. And I was wondering, we've now looked at explainability and this trade-off only in terms of introducing an additional constraint into an optimization problem, which would reduce the quality of the solution. I was wondering if there's other completely different approaches to improve the way that AI could be trained and the degree to which it could be explainable, other than the actual training procedure. I was wondering if limiting or just having a better idea of the training data that goes into an AI could help us explain and understand its decisions.
That's
and
absolutely
outcomes.
true. You know that probably the largest part of data with which the nowadays large language models are trained is called C4. There's I don't remember what the 4C stays for, but in any case. And for example, looking at the output of, okay, let's mention it for the third time, ChatGPT, they realized that the sampling of the literature is widely uneven because there are 50 books that have been passing through these weights for training much more than others because their answers on these books are much more accurate than everything else. So probably sometimes the data with which something has been trained are part of a possible explanation of the behavior. That's for sure. This is why we should take a lot of caution in preparing the data set, which is something I'm not sure has been done now, up to now, but I'm pretty sure that will be done in the future. It will be done in the future because we are beginning to realize that this is important. I don't think that OpenAI has taken particular care in selecting an even coverage of English literature, Italian literature, and so on. It simply took a lot of language produced by human beings and trained with that. While we progress on this awareness, probably we will realize that part of the explainability is in the data we use, especially of the weird behaviors, and we will take more care in designing the data set.
Just briefly, could you please go back to that slide where you mentioned the applications? Where I think before, yeah, after that one, yes, the one on the trade-offs we're examining. I want to ask you about where do you see this line happening? Because here we have certain applications where the AI system is being used mostly for scientific or scientific-ish purposes, where you want to find a result. And sometimes it's acceptable to have something like a gut feeling that you can go on later and justify, but still can act on that. Whereas, for example, the public administration case, you have something that's a decision with effects that might require some sort of justification. Do you think there is a difference here on the degree of on the uses that you're doing to this factor in terms of justifying whether we can forsake explanation or because it would be
okay, to be honest, I have chosen these 4 bullets because I have some knowledge about problems that have occurred in the past. For example, in the Italian school, the assignment of professors and so on, it was not AI by far, of course, not the large language model or deep neural network, but in any case, there was Consiglio di Stato, I don't know what was the body ruling. Okay, decided that it could not be done simply, and this is the criterion that I use because, for example, diagnosis of difficult pathologies, there is a very famous application that was the first one to be approved by the FDA in the US to diagnose it's about the glaucoma given by diabetes, something like this, starting from the images of the retina. And so it is a certified application. So this is the idea that I had in mind. And of course, the therapies, because they have the concoction of different drugs for making cancer treatments and so on. There are true applications for this. This is my main criterion for choosing. And of course, I see some differences. There are some differences. Some of them are life-threatening things that some others are not, of course. And I like this because I take from the fact that they have differences, the fact that I can address them in a different way. Just like Nicolas was saying, we should have probably a different trade-off curves for each of them and discuss quite thoroughly what to apply to each of them. I think so.
One thing that you didn't discuss, because you had this kind of idea of explainability as something which is internal to the system, but some people say, okay, but we don't need that. Let us just do sensitivity analysis and see what kind of features would have, had it been different, would have led to a different result, or let us have ex post generation of explanation, which is what also humans do. So you can have your what do you think of this kind of thing?
Yes, I perfectly agree. This again brings me to the what's an explanation? Where is it? I want to concentrate on this kind of explanation because I feel this is the only true explanation. But you are perfectly right in saying, where is it? Okay, you're perfectly assumed. Actually, the first trials in explaining things were sensitivity analysis. Okay, on images typically, because they propagated back the gradient at every classification and say what was the area of the picture that made the decision change most. And that's perfectly true. I have this problem. Once you know that, for example, huskies are classified as huskies because they have snow in the background, how do you classify like wolves? I mean, how do I have to change the background for this? I mean, sensitivity analysis doesn't tell you this, because it is a sensitivity means that there's a working point established, and then I see variations around. Like, it is a perfectly sensible explanation. I like it. Of course, I know that human beings like it and feel convinced by this, but this is not a full explanation in my mind, because it doesn't allow you to propagate this knowledge to a different case. And so it is just a partial explanation in what I see. Of course, as I probably commented before, it may be that if you lower the level of strength of the explanation you're requiring, probably the trade-off will be looser. I think so. I think it's quite convincing.
Yeah, I more trivial or pedestrian question, a mundane question. So what is the top #1 priority area for regulation in relation to these systems, in your view? If that one thing has to be regulated now, what is it?
In my mind, I'm quite ignorant of what is already there. Okay, so starting from this, I would say that the top priority would be people to be aware that there's a trade-off. Okay, so don't ask for explainability straightforward. Just think 5 minutes about it. What's your it is exactly what you were saying. So, okay, what is your expectation? What is your application? What's the criticality of what you're asking? So, can I ask anybody to study this problem for me, for example, before I simply say, okay, this cannot be done. This has to be done like this. I remember, I don't know whether it is still there in the AI Act, but there's one way, one paragraph that says that data may be without errors. Oh my God. So that was written because they had in mind personal data, for sure, because the first wave of concern was about personal data. And even in that case, it's impossible to have a big data set without error. That's impossible. So, and now that we come to machine generated data, saying that it is without error is something that make any technicians laugh. So data are full of errors. So if we stick to the rule, we don't use machine data, because let me make an example, which is a very technical one, but we are dealing with predictive maintenance for satellites with Thales Alenia, okay? Because instead of coming here and having good times with social scientists, sometimes I also an engineer, so I work on engineering problems, and they want to know what will be the remaining useful life of satellites, because nowadays they establish it on the ground. They say, okay, 10 years, and after 10 years, they blow it up. That's nothing else. Now, they have a lot of data coming down, so let's study them. And the problem is, oh, sorry, I completely lost my line.
Satellites, the line.
No, that's not the point. What was your question? I'm sorry, Nicholas. I'm so tired. It's the second hour.
You said, we had this error-free requirements.
Yes, that's it. Okay, thank you. And if you look at the data, they are extremely well constructed, collected, acquired data. Once every hour, we are missing some sample. Once every hour, and they stay there up to 10 years. So they are not without errors. They are full of errors. And we have to cope with them. We don't have to say, if you have errors, you cannot develop an application. If I were in the regulator, I would have written, you have the responsibility of coping with errors. Not it must be without errors. It has a big difference. So to come to the first question, I think that the first point is to make people making regulations aware that there is a trade-off. They cannot ask for anything everywhere, every time. Is it too trivial?
No, that's great.
Here's another question in the chat. What do you think about this new stream of literature on data sheets for data sets? Data sheets for data sets, model cards or impact assessments as a possible solution to the explainability conundrum.
I have to confess my ignorance.
You have it.
Probably
in the chat, maybe. If you look it in the chat on the computer.
Okay, how do I do it?
Model cards or impact assessments.
Yeah,
Yes.
impact assessment.
Check in advance the impacts of the system.
Don't know this, sorry. Cannot comment on this. So I don't know technically the mechanism, so.
It's a bit late. I think that the idea is that you should, when you, if I understand that, I'm not sure. Maybe it's better if the first one.
Okay.
Natalia, if you want to.
Yeah,
intervene.
sure.
Thank
sure.
you. I need some more detail because as you stated it, I don't recognize the.
Yeah,
the
no,
technique.
it's basically a new, I think it's actually not new. It has maybe a couple of years. There were a couple of papers, I think, on the context of the Fairness, Accountability and Transparency Conference, and also some work by Margaret Mitchell, for example. So it's basically, as far as I can explain, and don't take my words literally, but kind of the same approach as in technical documentation. But for example, on data sets, like how they are composed, where the data taken
this is what you
from.
find on Kaggle, for example. Yes. Okay.
Yeah. And as far as I know, this is like the latest solution, or the solution also that convinced me the most to solve the explainability problem as it is right now. Okay, but as we have seen in the talk, it's a big problem.
Okay.
But
So now I understand. Yes. Okay. This may solve the data part of the explainability. Then something else happens every time you make an inference, and this is what we still have to explain. And there's not much more I can tell you because this has to do with data. And I understand this may be one of the tools that we are using, taking the analogy of the toolbox from your colleague here. And for sure, it will be one of the, but not the definitive one. I don't see how it can explain everything that happens at inference time.
okay, thank you.
It's 5 p.m. sharp, so I think we have
And
used and abused.
I've lost my line for you.
So I think it was great. Thanks a lot, Riccardo, for your
Thanks to you.
availability, the discussion, which was great. Thanks to the audience for the great questions as well.
Great question.
Thanks a lot.